February 3, 1945. 4:47 hours. Imperial Japanese Army Headquarters, Manila, Philippines. Colonel Takeshi Yamamoto's fountain pen hovered over the intelligence report as cigarette smoke curled through the dim lamplight of his office. The Americans cannot sustain their advance. Their supply doctrine is chaotic, wasteful, impossible at scale. He underlined the phrase twice, nodding to himself as he reviewed intercepted communications detailing Allied logistics operations across the European theater. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed, because tomorrow, I've saved something extra special for you. Through the window, the pre-dawn darkness concealed the approach of American forces that would overrun his position within 72 hours. What Yamamoto didn't know, what none of the Imperial staff officers comprehended despite years of meticulous intelligence gathering, was that the vehicle they dismissed as a crude utility runabout had already rewritten the fundamental mathematics of modern warfare. The Japanese had studied German reports. They had analyzed British assessments. They had intercepted American supply manifests. Every calculation pointed to the same conclusion: the American logistical system was bloated, inefficient, dependent on infrastructure that didn't exist in combat zones. The numbers seemed irrefutable. American units consumed fuel, ammunition, and supplies at rates that exceeded any sustainable delivery system. German forces in North Africa had strangled on extended supply lines stretching mere hundreds of kilometers. The Japanese themselves had mastered the art of light infantry operations precisely because heavy logistics were untenable in Pacific Island campaigns. Yet somehow, impossibly, American forces were advancing on multiple fronts simultaneously, maintaining offensive momentum that should have collapsed under its own logistical weight. Colonel Yamamoto filed his report with confidence. The American system would break. It had to break. Mathematics demanded it. What he couldn't see from his Manila headquarters, what became invisible in the careful columns of supply statistics and fuel consumption rates, was a revolution in military mobility so profound that it would render obsolete every assumption about how armies moved, fought, and sustained themselves in hostile territory. In exactly 19 days, when American forces reached the Rhine River and prepared for the final push into Germany, they would do so supported by a logistics network moving more tonnage per day than the entire Imperial Japanese Army consumed in a month. The vehicle enabling this impossible feat weighed less than 1.5 tons. It had been designed in just 48 hours. And 640,000 of them were already deployed across every theater of war, creating a logistics revolution that military theorists would study for the next 8 decades. The genesis of what would become the most influential military vehicle in history began not in some grand strategic vision, but in a desperate scramble to solve a problem that threatened to undermine American military effectiveness before the nation even entered World War II. In July 1940, with war consuming Europe and the American military beginning its transformation from a constabulary force into a modern army, the Quartermaster Corps faced an existential crisis. The existing vehicle fleet, a hodgepodge of civilian trucks and outdated military designs, couldn't meet the demands of mechanized warfare. The U.S. Army's leadership had watched with growing alarm as German forces swept through Poland and France with unprecedented speed. The Blitzkrieg wasn't just about tanks and aircraft. It was fundamentally about logistics, about moving supplies, troops, and equipment faster than defenders could react. American planners recognized that matching this operational tempo would require a complete reimagining of military transport. Traditional trucks were too large, too specialized, too slow for the fluid battlefield conditions of modern war. On June 27, 1940, the Army Quartermaster Corps issued a specification that seemed almost impossible to fulfill. They wanted a light reconnaissance vehicle weighing no more than 1,300 pounds, capable of carrying a 600-pound payload, with four-wheel drive, a low silhouette, and the ability to traverse terrain that would stop conventional vehicles. The specifications included rectangular body lines for simplicity, a fold-down windshield for reduced profile, and the capacity to operate on roads, trails, or cross-country with equal facility. Perhaps most demanding of all, they wanted prototypes delivered for testing in just 49 days. 135 automotive manufacturers received the invitation to bid. 132 declined or never responded. The technical requirements seemed contradictory. High ground clearance for obstacle crossing conflicted with low center of gravity for stability. Lightweight fought against structural durability. Four-wheel drive added complexity and weight. The timeline was absurd. Normal vehicle development took years, not weeks. Only 3 companies accepted the challenge. American Bantam Car Company of Butler, Pennsylvania took the lead, largely because they were desperate for any contract that might save their failing business. Bantam had been producing small economy cars since 1930, competing unsuccessfully against larger manufacturers. By 1940, they were on the verge of bankruptcy, operating with a skeleton crew and outdated equipment. The Army contract represented their last chance for survival. Chief Engineer Carl Probst received a phone call on a Thursday evening requesting his presence in Butler by Monday morning to lead the design effort. Probst arrived to find a company with enthusiasm but almost no engineering resources. The design work would have to be completed in days, not months. Working essentially alone, Probst spent the next 18 hours sketching the fundamental architecture of what would become the Jeep. He borrowed liberally from existing designs. The chassis came from Bantam's commercial car line. The engine would be sourced from Continental Motors. The transfer case and axles would come from Spicer Manufacturing. Nothing about the design was revolutionary in isolation. The genius lay in the integration, in combining proven components into a configuration optimized for military utility. The design that emerged from those frantic days of work was starkly utilitarian. A simple ladder frame chassis supported a boxy body with minimal bodywork. Four-wheel drive provided traction. High ground clearance allowed obstacle crossing. The fold-down windshield reduced shipping height and provided some protection when firing weapons over the hood. Every element served a specific military function. Nothing was included for comfort, appearance, or civilian appeal. It was a tool, pure and simple, designed to do a job. Bantam delivered their prototype, designated the Bantam Reconnaissance Car, on September 23, 1940, just 2 days past the impossible deadline. Army testing at Camp Holabird, Maryland revealed a vehicle that exceeded specifications in almost every category. It could climb grades steeper than 45 degrees. It could ford streams 30 inches deep. It could operate cross-country at speeds that left observers astonished. Most importantly, it proved remarkably reliable despite its hasty development and lightweight construction. But the Army faced a dilemma. Bantam lacked the production capacity to build vehicles in the quantities military mobilization would require. Their entire factory could produce perhaps 50 vehicles monthly. The Army would need thousands, then tens of thousands, eventually hundreds of thousands. The solution was pragmatic if somewhat ruthless. The Army took Bantam's design and invited Willis Overland and Ford Motor Company to submit their own versions based on Bantam's engineering. Willis Overland of Toledo, Ohio brought significant advantages. They had been building cars and trucks since 1908 and possessed both engineering expertise and manufacturing capacity that dwarfed Bantam. Their chief engineer, Delmar Roos, refined Bantam's design with several key improvements. Most significant was the engine. Willis equipped their prototype with their own 4-cylinder power plant, the Go Devil engine, producing 60 horsepower compared to the Bantam's 45 horsepower Continental unit. This seemingly modest increase transformed the vehicle's capabilities. The additional power allowed the Willis design, designated the Willis Quad, to carry heavier loads while maintaining mobility. It could tow artillery pieces that stalled the Bantam. It could climb steeper grades with full loads. The engine proved remarkably robust, capable of preparing and narrating this story took us a lot of time, so if you are enjoying it, subscribe to our channel, it means a lot to us. Now back to the story. Sustained operation under conditions that would have destroyed more sophisticated power plants. Willis also strengthened the frame and suspension, adding weight but dramatically improving durability. The result was a vehicle that exceeded the original 1,300-pound weight specification, coming in at around 2,450 pounds, but provided capabilities that justified the extra mass. Ford Motor Company entered the competition with characteristic efficiency. Henry Ford had built his empire on mass production, and the Ford design reflected this heritage. The Ford Pygmy, as their prototype was designated, incorporated numerous features designed to simplify manufacturing. Stamped components replaced more complex assemblies. Parts were designed for interchangeability. The body was simplified even further than Bantam's original. Ford's contribution wasn't in revolutionary engineering but in manufacturing efficiency, in creating a design that could be produced in unprecedented quantities with minimal tooling and training. Army testing through late 1940 and early 1941 evaluated all three designs exhaustively. Each had strengths. Bantam was lightest and most agile. Willis was most powerful and durable. Ford was easiest to manufacture. In a decision that would prove controversial for decades, the Army chose Willis as the primary design, largely due to the superior engine performance, but mandated that all three manufacturers would produce vehicles to a standardized specification incorporating the best features of each design. The standardized vehicle that emerged from this process received the designation truck, quarter-ton, 4x4. The name Jeep, which became universal among troops and eventually official, had murky origins. Some claimed it derived from the military designation GP for general purpose. Others traced it to Eugene the Jeep, a character from the Popeye comic strip known for going anywhere and doing anything. Regardless of etymology, the name stuck, becoming synonymous with the vehicle itself. Production began in earnest in 1941. Willis received the largest contracts, eventually producing over 360,000 units. Ford, under license from Willis, built approximately 280,000 vehicles to the same specifications, designated the Ford GPW. Total production across all manufacturers and variants would eventually exceed 640,000 vehicles by war's end, making it one of the most produced military vehicles in history. The scale of this production represented a remarkable achievement in industrial mobilization. To put these numbers in perspective, consider that the entire German Wehrmacht never operated more than 400,000 trucks of all types simultaneously. The Americans produced more Jeeps alone than Germany produced total military vehicles during the entire war. This disparity in industrial capacity would prove as decisive as any tactical innovation or strategic brilliance. Wars are fought with bullets and shells, but they're won with supply tonnage and vehicle kilometers. The Jeep's specifications revealed a vehicle optimized for versatility over specialization. Length measured 132 inches. Width spanned 62 inches. Height with top erected reached 72 inches, though the canvas top was often removed in combat. Wheelbase of 80 inches provided stability while allowing a tight turning radius of just 17.5 feet. Ground clearance of 8.75 inches allowed crossing obstacles that would stop conventional vehicles. The approach angle of 45 degrees and departure angle of 35 degrees meant the Jeep could climb over and off obstacles without grounding its chassis. The powertrain centered on the Willis Go Devil engine, a 134 cubic inch inline four-cylinder producing 60 horsepower at 4,000 revolutions per minute and 105 pound-feet of torque at 2,000 revolutions per minute. These numbers seem modest by modern standards, but the engine's character made it ideal for military service. Maximum torque arrived at low engine speeds, providing pulling power where it mattered most. The engine ran on low-octane gasoline, critical in theaters where fuel quality was inconsistent. It could operate in extreme temperatures from Arctic cold to desert heat. Most importantly, it was nearly indestructible, capable of running with minimal maintenance under conditions that would have killed more sophisticated power plants. Power transferred through a 3-speed manual transmission with synchromesh on second and third gears to a 2-speed transfer case providing high and low range. In low range, the Jeep could climb obstacles at walking pace with extraordinary pulling power. High range provided road speeds up to 65 miles per hour, though cruising speed was typically limited to 45 to 50 miles per hour for fuel economy and mechanical preservation. Four-wheel drive could be engaged at any speed, unusual for the era, allowing drivers to maintain momentum when transitioning from firm to soft terrain. The suspension used semi-elliptic leaf springs at all four corners, a simple robust design that provided surprising wheel travel and articulation. Military drivers discovered that the Jeep could traverse terrain that appeared impossible. Three wheels could be off the ground with the fourth maintaining traction. The flexible frame actually helped in extreme terrain, twisting to follow ground contours that would have broken a rigid structure. This flexibility, combined with high ground clearance and aggressive tire tread, gave the Jeep mobility that rivaled tracked vehicles in many conditions. Payload capacity was rated at 800 pounds, though field use often exceeded this dramatically. A typical combat load included driver, 3 passengers with full combat equipment, ammunition, water, fuel cans, radios, weapons, and miscellaneous supplies, easily exceeding 1,000 pounds. The Jeep carried this weight reliably, though ride quality degraded considerably when overloaded. Soldiers learned that the Jeep would carry almost anything if loaded properly and driven with some mechanical sympathy. Fuel capacity of 15 gallons provided a range of approximately 200 miles under ideal conditions. In practice, combat operations reduced range significantly. Cross-country driving, frequent stops and starts, and cold weather operation could cut fuel economy in half. The Jeep consumed fuel at a rate of about 7 to 8 miles per gallon under typical military use. This consumption rate, multiplied across hundreds of thousands of vehicles, would drive logistics planning throughout the war. The vehicle's simplicity extended to controls and operation. Clutch, brake, and accelerator pedals operated conventionally. A floor-mounted shift lever controlled the transmission. A smaller transfer case lever engaged four-wheel drive and low range. The steering wheel connected to a simple worm-gear steering box, providing 3 3/4 turns lock-to-lock. There were no hydraulic systems except brakes. No power steering. No power brakes. Everything operated mechanically, which meant maintenance could be performed with basic tools and minimal training. This mechanical simplicity proved crucial in field conditions. A competent mechanic could repair almost any failure with improvised tools and scavenged parts. Soldiers with no formal training learned to perform basic maintenance. The design tolerated abuse that would have destroyed more sophisticated vehicles. Engines ran thousands of miles between overhauls. Transmissions and transfer cases, if properly lubricated, lasted indefinitely. The Jeep didn't break down often, and when it did, it could usually be fixed quickly with minimal resources. Early tactical employment of the Jeep in 1941 and 1942 focused on its original reconnaissance mission. Light, fast, and agile, it could probe enemy positions and report back quickly. But field commanders almost immediately began discovering applications far beyond the original specification. The Jeep's versatility stemmed from its fundamental design philosophy: provide mobility and carrying capacity, then let soldiers figure out how to use it. This open-ended utility made it invaluable in ways engineers never anticipated. In North Africa, where American forces first engaged German troops in large-scale combat, the Jeep's capabilities became immediately apparent. The desert terrain, alternating between hard-packed sand and loose dunes, rocky wadis and flat plains, demanded vehicles that could traverse any surface. British forces had struggled with logistics, depending on trucks that could only use established roads. German forces, equipped with specialized desert vehicles, could move cross-country but in limited numbers. The Jeep could go anywhere in any quantity. American logistics officers discovered that Jeeps loaded with jerry cans could deliver fuel and water to forward positions that trucks couldn't reach. The same vehicles evacuated wounded, carried ammunition, towed artillery, and performed reconnaissance. The flexibility proved revelatory. A Jeep didn't have a single mission. It performed whatever mission the situation demanded. This adaptability became force multiplication. One vehicle type could replace a dozen specialized designs, dramatically simplifying supply chains and maintenance requirements. The invasion of Sicily in July 1943 demonstrated the Jeep's strategic value on a larger scale. The island's terrain, mountainous and crisscrossed by narrow roads and cart paths, seemed impossible for mechanized forces. German commanders assumed the terrain would slow American advances to a crawl, buying time for reinforcement and defense. Instead, American units used jeeps to bypass road networks entirely, moving through terrain the Germans considered impassable. Artillery towed by jeeps climbed mountain tracks. Supply columns using jeeps delivered ammunition and rations to forward positions without using roads. Reconnaissance patrols and jeeps probed defenses, finding weak points and guiding attacks. The Italian campaign that followed Sicily reinforced these lessons. Italy's geography, a mountainous peninsula with limited road networks concentrated in valleys, should have created defensive advantages favoring the Germans. American forces negated these advantages through superior mobility. Where German logistics depended on vulnerable road networks that could be cut by air attacks or partisan operations, American supply lines dispersed across the landscape, using jeeps to deliver supplies via countless small routes that couldn't all be interdicted. General George Patton, commanding American forces in Sicily and later in Europe, recognized the jeep's strategic significance early. He wrote in a letter to the War Department that the jeep, more than any other vehicle, enabled the American way of war, our ability to strike where the enemy doesn't expect, to sustain operations beyond what our logistics should support, to maintain tempo that prevents the enemy from recovering. Patton understood that modern warfare rewarded speed and flexibility over mass and firepower. The jeep provided both in a package that could be produced and fielded in overwhelming numbers. Planning for Operation Overlord, the invasion of Normandy, incorporated lessons learned from North Africa and Italy. Logistics officers calculated that supporting 7 Allied divisions during and after the invasion would require moving 40,000 tons of supplies daily. Traditional logistics doctrine suggested this was impossible without extensive port facilities, which wouldn't be available until Cherbourg was captured and repaired. The solution was revolutionary: create a logistics network that didn't depend on traditional infrastructure, using the jeep as the fundamental unit of delivery. The plan called for supplies to be unloaded on the beaches, consolidated in forward supply depots, then distributed to combat units using vehicle convoys. The system depended on having enough trucks and jeeps to maintain continuous movement from beach to front line and back. Calculations indicated that the invasion force would need at least 50,000 jeeps in the first 3 months, with production continuing to support operations as forces expanded inland. American factories, already producing jeeps at rates exceeding 3,000 per week, accelerated further to meet demand. D-Day, June 6, 1944, saw jeeps landing within the first hours of the invasion. Combat engineers drove jeeps off landing craft into chest-deep water, waterproofing systems allowing engines to run while submerged. These first vehicles established communication networks, evacuated wounded, and guided follow-on forces off the beaches. Within 24 hours, hundreds of jeeps were operating throughout the beachhead, creating a nervous system that coordinated the vast organism of the invasion force. The breakout from Normandy in August 1944, Operation Cobra, demonstrated how completely the jeep had transformed military operations. American forces advanced so rapidly that supply lines stretched to breaking point. Conventional logistics doctrine would have required pausing to consolidate supply lines. Instead, American commanders kept advancing, trusting their jeep-based logistics network to keep pace. The trust proved justified. Convoys of jeeps, operating off-road when necessary, delivered fuel and ammunition to forward units even as those units raced across France at speeds exceeding 50 miles per day. The Red Ball Express, established in August 1944 to supply Patton's Third Army during its race across France, became the most famous logistics operation of the war. The system used dedicated routes, operated around the clock, and moved exclusively toward the front with loaded vehicles, returning empty to reload. At its peak, the Red Ball Express operated over 6,000 trucks, but jeeps formed the connective tissue that made the system work. Jeeps guided convoys, delivered priority cargo, evacuated broken vehicles, maintained communications, and performed countless other functions that kept supplies flowing. Japanese observers, monitoring Allied operations in Europe through diplomatic channels and intelligence reports, struggled to comprehend what they were seeing. The numbers didn't make sense. American forces were advancing on broad fronts while simultaneously maintaining offensive operations in Italy, preparing for further landings in southern France, and conducting strategic bombing campaigns requiring immense logistical support. The tonnage requirements seemed impossible to sustain. Japanese logistics officers, trained in the careful mathematics of supply management, calculated that American supply lines should have collapsed by September 1944. Instead, they continued operating at full capacity. What Japanese analysts missed, what remained invisible in dry logistics reports and supply statistics, was the fundamental change in logistics doctrine that the Jeep enabled. Traditional logistics worked linearly. Supplies moved from ports to railheads to forward depots to combat units along carefully planned routes using specialized vehicles for each leg of the journey. This system was efficient but fragile. Disrupt any point in the chain, and the entire system faltered. The Jeep created a different model, a distributed network where supplies could flow through countless small channels, self-organizing around obstacles and disruptions. Field commanders discovered that a company with 20 Jeeps could maintain itself indefinitely as long as supply depots existed anywhere within 50 miles. The Jeeps would self-organize, finding routes to depots, loading supplies, and returning to the company. No formal supply chain was necessary. No specialized transport units. The organic mobility within the company was sufficient. This capability meant that American units could operate with independence impossible for forces dependent on conventional logistics. The liberation of Paris in August 1944 illustrated this principle dramatically. As American forces approached the city, resistance forces inside Paris rose in rebellion. The uprising threatened to fail from lack of supplies until American commanders began dispatching Jeep convoys directly into the city while it was still contested. These small, fast vehicles slipped through German positions, delivered weapons and ammunition to resistance forces, and evacuated wounded. Larger vehicles would have been intercepted. The Jeeps succeeded through sheer audacity and mobility. The advance to the German border in September 1944 finally stretched even the Jeep-enabled logistics network to breaking point. Patton's Third Army, racing northeast toward the Saar, and Montgomery's forces, driving toward the Netherlands, both outran their supply lines simultaneously. For the first time since Normandy, major operations had to pause while logistics caught up. But even this pause revealed the Jeep's revolutionary impact. The forces had advanced 400 miles in 3 weeks, maintaining combat effectiveness throughout. No army in history had sustained such operational tempo over such distances. The Market Garden operation in September 1944, despite its ultimate failure to secure a crossing of the Rhine, demonstrated innovative Jeep employment. British airborne forces, landing near Arnhem, included Jeeps delivered by glider. These vehicles provided mobility that transformed the capabilities of parachute infantry. Where traditional airborne forces were essentially immobile once landed, depending on what they carried or could capture, the Jeep-equipped units could range across the battlefield, concentrate forces, and conduct mobile operations. The concept would influence airborne doctrine for decades. Winter 1944 brought the Battle of the Bulge, Germany's last major offensive in the West. German planners specifically targeted American supply lines, hoping to create chaos in the logistics network supporting Allied forces. The plan assumed that winter conditions, difficult terrain, and disrupted supply routes would paralyze American response. Instead, the Jeep-based logistics network proved remarkably resilient. Individual Jeeps and small convoys found routes through the confusion, delivering ammunition and evacuating wounded even as German forces cut major supply routes. The defense of Bastogne illustrated this resilience. Surrounded American forces included the 101st Airborne Division and attached units, approximately 18,000 troops. Conventional wisdom suggested that surrounded forces would run out of ammunition and supplies within days. Instead, Jeep-equipped supply units operating individually or in small groups repeatedly broke through loose German encirclement, delivering critical supplies. The vehicle's small size, cross-country mobility, and speed allowed them to infiltrate where larger convoys would have been destroyed. The spring offensive of 1945 revealed the full maturity of Jeep-enabled logistics doctrine. As Allied forces prepared to cross the Rhine and drive into the heart of Germany, the scale of operations dwarfed anything previously attempted. 7 Allied armies, comprising over 3 million troops, would advance simultaneously on fronts stretching from the Netherlands to Switzerland. Supporting this force required moving 800,000 tons of supplies weekly, equivalent to emptying a Liberty ship every 7 minutes, 24 hours a day, 7 days a week. Traditional logistics planning suggested this was impossible without months of preparation and massive port facilities. American logistics officers proposed something different. They would create a rolling supply system, where supplies moved continuously from rear areas to forward units without intermediate stockpiling. The system depended entirely on having sufficient vehicles to maintain constant motion. Calculations indicated they needed at least 100,000 Jeeps dedicated solely to supply operations, separate from the vehicle's organic-to-combat units. By March 1945, they had over 150,000 Jeeps available in the European theater alone. The crossing of the Rhine at Remagen on March 7, 1945 demonstrated this system's flexibility. When American forces unexpectedly captured the Ludendorff Bridge intact, commanders faced a critical decision. Exploiting the crossing required immediately pushing forces across before Germans could react, but doing so meant advancing without prepared supply lines. Traditional doctrine would have suggested consolidating before crossing. Instead, American commanders ordered immediate exploitation, trusting Jeep-based logistics to improvise supply lines. Within 6 hours of the bridge's capture, Jeeps were crossing loaded with ammunition and fuel. Engineers constructed additional temporary bridges specifically designed to carry Jeep traffic, lighter structures that could be erected in hours rather than days. Within 48 hours, a self-organizing supply network was operating across the Rhine, with hundreds of Jeeps shuttling supplies to expanding bridgeheads. German counterattacks aimed at destroying the bridge found themselves engaging American forces already well supplied and entrenched, the rapid logistics buildup negating the advantage surprise should have provided defenders. The exploitation phase following Rhine crossings revealed patterns that Japanese observers found incomprehensible. American armored divisions, spearheading the advance into Germany, moved at speeds exceeding 40 miles per day while maintaining full combat capability. German forces, falling back toward defensive positions, expected pursuing forces to outrun their logistics and pause. Instead, American units maintained contact continuously, never allowing German forces time to establish new defensive lines. The secret was simple but revolutionary. Each American armored division included organic Jeep-equipped supply companies that could operate independently for extended periods. These units didn't wait for supplies to arrive through formal logistics channels. They sent Jeeps back to wherever supplies existed, loaded everything available, and returned to their divisions. If formal supply depots were too distant, Jeeps intercepted supply convoys heading toward other units, negotiated or commandeered what they needed, and continued forward. The system was chaotic, violated every principle of organized logistics, and worked brilliantly. German commanders, trained in methodical logistics planning, couldn't counter this approach. They would prepare defensive positions, expecting American forces to pause while supplies caught up, then discover American units attacking with full ammunition loads and fuel tanks. The Germans would fall back to new positions, and the pattern repeated. The inability to gain time for preparation or reinforcement meant German defensive efforts collapsed continuously, the front rolling back toward Berlin faster than reserves could be repositioned. Lieutenant Colonel Heinrich Vogel, commanding a Wehrmacht logistics battalion in April 1945, recorded his observations in a diary later captured by American forces. The Americans fight as if logistics don't exist. They advance without visible supply columns. Their forward units operate as if connected by invisible threads to unlimited resources. We destroy their supply routes, yet their attacks continue without pause. It defies every principle of military science we have studied. Our own forces halt for lack of fuel while Americans, advancing across devastated countryside without functioning rail networks, somehow maintain offensive operations indefinitely. Vogel's confusion was understandable. German logistics doctrine, highly developed through years of mechanized warfare, emphasized efficient use of limited resources through careful planning and centralized control. Supply convoys moved on schedule along predetermined routes to established depots where units drew rations based on calculated requirements. The system worked well when infrastructure remained intact and operations proceeded according to plan. It collapsed when faced with the fluid chaos of actual combat in 1945. American logistics, built around the Jeep's flexibility, operated on different principles. Instead of centralized planning and scheduled movements, the system embraced controlled chaos. Unit supply officers had authority to acquire supplies however necessary. If formal requisitions were too slow, they traded with other units, diverted supplies from passing convoys, or sent jeeps to scavenge from rear area depots. This decentralization looked like chaos but proved remarkably efficient because it allowed the system to self-organize around disruptions. The mathematics of this approach revealed why it worked where conventional logistics failed. A traditional supply convoy of 10 trucks, moving on a single route, represented a single point of vulnerability. Destroy the convoy, and supplies didn't arrive. 100 jeeps, moving individually or in small groups on dozens of routes, represented a distributed network. Destroying 10% of them still meant 90% of supplies arrived. The redundancy made the system nearly impossible to disrupt completely. The Pacific Theater, where Japanese forces faced similar jeep-enabled logistics, provided parallel lessons. The island-hopping campaign created unique logistics challenges. Each captured island needed immediate supply buildup to support operations against the next objective, but islands typically lacked port facilities and road networks. Traditional logistics required extensive time-building infrastructure before forces could be adequately supplied. The Jeep changed this calculation entirely. When Marines landed on islands, Jeeps landed with them in the first waves. These vehicles operated on beaches, in jungles, across volcanic terrain, creating supply networks before any roads existed. Supplies unloaded on beaches went directly to frontline units via Jeep, bypassing the need for intermediate depots or formal supply routes. This capability meant American forces could maintain offensive momentum immediately after landing, before defenders could organize cohesive resistance. The Battle for Okinawa, April through June 1945, demonstrated this advantage decisively. Japanese defenders, expecting American forces to pause after landing while establishing logistics, planned their defense accordingly. Instead, American units advanced immediately, supplied by jeeps operating across terrain Japanese commanders assumed was impassable for vehicles. The constant pressure prevented Japanese forces from executing their planned defense in depth, forcing them into costly counterattacks that depleted their strength. Japanese logistics officers, observing American operations on Okinawa, filed reports noting that American supply operations appeared to violate fundamental principles of military logistics. Supply tonnage delivered to forward units exceeded what the visible infrastructure could support. Units maintained operations at distances from supply bases that should have left them immobile. The explanation, that thousands of small vehicles were creating an invisible supply network, seemed too simple to explain the observed effects. General Mitsuru Ushijima, commanding Japanese forces on Okinawa, recognized the implications. In a communication to Imperial Headquarters dated May 15, 1945, he wrote that the Americans have solved the fundamental problem of military operations, the tyranny of distance. Their small vehicles, individually insignificant, collectively create a logistics capability that renders traditional defensive planning obsolete. We calculate they cannot sustain operations at observed distances from their supply bases. Yet they continue to attack with undiminished strength. Our calculations are correct, but our premises are wrong. Ushijima's observation identified the core revolution the Jeep enabled. Military operations had always been constrained by logistics. An army could only fight as far as it could be supplied. This fundamental limitation shaped strategy for millennia. Fortifications were effective because attackers eventually outran their logistics. Defensive terrain was valuable because it forced attackers to extend supply lines. The mathematics of supply tonnage versus distance created predictable limits on operational reach. The Jeep didn't eliminate these constraints, but it dramatically extended them. Where conventional logistics might support operations 50 miles from a supply base, Jeep-based logistics could sustain forces 100 miles out. This doubling of effective operational reach meant maneuver space doubled, strategic options multiplied, and defensive advantages based on distance calculations became much less effective. The change was as significant as improvements in weapons range or movement speed. In the Philippines, where American forces conducted extensive operations through 1945, the Jeep's impact on counterinsurgency operations proved equally significant. Japanese forces, retreating into mountainous terrain, expected to conduct guerrilla operations from positions American forces couldn't effectively reach. Mountain trails and jungle paths, impassable for trucks, should have created safe havens. Instead, Jeeps reached these areas easily, allowing American forces to maintain pressure against Japanese holdouts that conventional logistics would have made unreachable. Filipino guerrilla forces, supplied and supported by American units, received Jeeps that transformed their effectiveness. Where guerrillas traditionally operated with whatever supplies they could carry or capture, American support delivered via Jeep provided sustained logistics. Guerrilla bands could now operate with heavy weapons, medical supplies, and communications equipment, transforming from harassment forces into effective light infantry. The strategic impact was profound, as Japanese forces found themselves fighting a two-front war with American conventional forces supported by Jeep logistics and guerrillas equipped through the same system. The final campaigns in Europe, April and May 1945, revealed the full evolution of Jeep-enabled operational doctrine. American and British forces advancing from the west, and Soviet forces advancing from the east, conducted operations on a scale unprecedented in warfare. The logistics requirements were staggering. American forces alone consumed over 800,000 tons of supplies weekly, including fuel, ammunition, rations, medical supplies, spare parts, and countless other items necessary for modern military operations. Supporting this consumption required a logistics network operating at maximum efficiency. By April 1945, the American logistics system in Europe included over 200,000 Jeeps dedicated to various supply, transport, and support functions. These vehicles moved constantly, creating a circulatory system that kept supplies flowing to hundreds of units spread across hundreds of miles of front. The system's scale and complexity exceeded anything previously attempted in warfare, yet it functioned reliably because it was built on simple, robust components operating under decentralized control. The race to Berlin, though ultimately conceded to Soviet forces for political reasons, demonstrated American capability to sustain deep penetrations. When Lieutenant General William Simpson's Ninth Army reached the Elbe River in April 1945, his forces were operating over 200 miles from their nearest major supply depots. Conventional logistics doctrine suggested this was beyond sustainable reach. Yet Simpson's forces were fully supplied, prepared to continue advancing if political considerations hadn't halted their movement. The logistics that sustained Simpson's advance operated almost invisibly. No massive supply convoys. No obvious supply routes. Instead, thousands of Jeeps moving individually or in small groups, using back roads, cross-country routes, and constantly shifting paths, delivered everything needed. German forces, still trying to interdict American logistics by attacking major routes, found their efforts increasingly futile. The Americans weren't using major routes. They were using every route simultaneously. Colonel Yamamoto, if he had survived to study these operations, would have recognized that his February 1945 assessment was fundamentally flawed. American logistics weren't chaotic or wasteful. They were adapted to a different operational philosophy. Where Japanese and German logistics emphasized efficiency through careful planning and resource conservation, American logistics emphasized resilience through redundancy and flexibility. The Jeep was the physical embodiment of this philosophy, a vehicle optimized not for any specific mission but for maximum adaptability. The industrial capacity that produced over 640,000 Jeeps during the war represented another dimension of American advantage. Willis Overland's Toledo factory operated 3 shifts daily, producing Jeeps continuously. Ford's factories added their production. The combined output exceeded 3,000 vehicles weekly at peak production, more than Germany produced in total vehicles some months. This production scale meant losses could be replaced immediately, damaged vehicles could be cannibalized for parts without impacting operations, and units could be equipped with Jeeps for missions never imagined in the original design. The versatility of the Jeep encouraged creative applications that multiplied its impact. Engineers mounted various weapons systems, creating mobile fire support. The Jeep could carry a 37mm anti-tank gun, a 50 caliber machine gun, or even a 75mm recoilless rifle in later configurations. Communications units installed radio equipment, creating mobile command posts. Medical units configured Jeeps as ambulances, adding brackets for stretchers. The basic platform supported endless modifications, each multiplying the vehicle's utility. Comparison with enemy vehicles revealed the Jeep's advantages. German forces operated various light vehicles including the Volkswagen Kübelwagen and the Schwimmwagen amphibious car. Both were competent designs, but production totaled only about 150,000 combined, less than a quarter of Jeep production. More significantly, German light vehicles were optimized for specific roles, reconnaissance and liaison, limiting their versatility. The doctrinal flexibility that made the Jeep invaluable to American forces had no equivalent in German operations. Japanese forces operated even fewer light vehicles, relying heavily on infantry movement and pack animals for logistics in difficult terrain. Their Type 95 mini-truck, the closest equivalent to the Jeep, was produced in minimal numbers and lacked four-wheel drive, limiting its utility in off-road conditions. Japanese logistics doctrine emphasized light infantry that could operate with minimal support, a doctrine developed partly from necessity given limited vehicle production but presented as virtue. Against an opponent with Jeep-enabled logistics, this approach proved disastrously inadequate. The training revolution that Jeep enabled affected American military effectiveness beyond pure logistics. Every soldier learned to drive, and most learned basic Jeep maintenance and repair. This universal mechanical competency created a force that could improvise solutions to problems, repair and modify equipment as needed, and operate semi-independently when circumstances required. German and Japanese forces, with more specialized training and rigid organizational structures, couldn't match this flexibility. American soldiers developed a relationship with the Jeep that transcended its function as a vehicle. It was a tool, a lifeline, a shelter, and a symbol of American industrial might. Soldiers knew that Jeep production exceeded enemy capabilities by orders of magnitude. They knew replacement vehicles arrived continuously. This knowledge created psychological confidence that extended beyond material advantages. The Jeep represented American abundance in a world of scarcity, proof that their nation's productive capacity exceeded anything enemies could match. The reliability that made the Jeep tactically useful also created strategic advantages through reduced maintenance burden. A typical Jeep required minimal scheduled maintenance, oil changes every 2,000 miles, lubrication every 500 miles, and basic inspections. Compare this to German vehicles requiring constant attention, complex maintenance procedures, and specialized tools. American mechanics could maintain 10 Jeeps in the time required to maintain one German equivalent vehicle, multiplying effective force size. Combat modifications demonstrated soldier ingenuity. Field units added armor plates to protect drivers, though this usually came from scavenged materials rather than factory modification. Some units mounted extra fuel cans, extending range for deep operations. Others added storage racks, increasing cargo capacity. The factory design was merely a starting point. Field modifications adapted the Jeep to specific unit needs, creating hundreds of variants all based on the same basic platform. The post-war period revealed the Jeep's lasting impact. American forces occupying Germany and Japan used jeeps extensively, providing mobility in areas where infrastructure remained damaged. The vehicles became symbols of American presence, their ubiquity demonstrating American capability to project force globally. Civilians in occupied territories quickly recognized the Jeep as representing American military power, the small vehicle carrying outsized symbolic weight. Military theorists studying the war's lessons focused extensively on logistics, recognizing that victory came not from superior tactics or weapons but from superior sustainment. The Jeep featured prominently in these analyses. Field manuals revised doctrine to incorporate lessons learned. The emphasis on mobility and flexibility, on distributed logistics networks and decentralized control, all drew directly from Jeep-enabled operations during the war. Soviet observers, studying American operations, drew their own conclusions. Their post-war light vehicle development reflected clear influence from Jeep design philosophy. The GAZ-69, entering service in 1953, borrowed heavily from Jeep concepts: four-wheel drive, lightweight construction, extreme simplicity. The Soviets recognized that the Jeep represented a revolution in military mobility and sought to replicate its capabilities in their own vehicles. The civilian market transformation the Jeep enabled proved almost as significant as its military impact. Returning soldiers, familiar with Jeep capabilities, created demand for similar civilian vehicles. Willis introduced the CJ Series, civilian Jeep, in 1945. These vehicles created an entirely new market category, the sport utility vehicle, that would grow to dominate American automotive sales by the late 20th century. The Jeep's influence extended far beyond military operations into broader transportation culture. Agricultural applications demonstrated the Jeep's utility beyond military contexts. Farmers discovered that Jeeps could traverse fields in conditions that stopped tractors, providing mobility during planting and harvest when time was critical. The power takeoff capability allowed Jeeps to operate farm equipment. Rural areas worldwide adopted Jeeps for their versatility and reliability, the same characteristics that made them militarily effective proving equally valuable in civilian applications. Emergency services adopted Jeeps widely in the post-war period. Fire departments used them for accessing remote areas. Up next, you've got two more standout stories right on your screen. If this one hit the mark, you won't want to pass these up. Just click and check them out.